here we're going to look at setting up an equation to solve this scenario. We're going to print some books and we're trying to decide which method to use. And you can probably see that one of them has a lower fixed cost but more cost per book, and another one has a higher fixed cost but it costs less per book. So thinking about that for a second, if we were only going to make a few books, this would certainly be cheaper to pay less up front and then make a few books. If we were going to make a whole bunch, maybe paying more up front to get this lower rate would be worth it. So what they're asking is, for how many books will the cost be the same? So even if we read the question, we can tell what to make our variable. They say how many books. So books is our unknown, so we could pick a letter for it, X, but if we want to be creative, like it B or something. And then when they say the cost be the same is an interesting keyword, because what they're asking is, when is this the same as this? Which means, when are these two methods going to be equal? So there's some point where it doesn't matter which one you do, and after that, this one's cheaper, and before that amount of books, or less than that amount of books, the other one's cheaper. So let's see if we can write a cost for each of them, and now we know we're setting them equal when we do. So for method A, $24.50 per book. So if I make 10 books, I have to pay $24.50 10 times. So you can see it's multiplication by the number of books. We already decided the number of books was, we were going to call it B. So this is $24.50 B, plus we have to pay this $21,193 no matter what. And we want to know, when is that equal to? On the other side, we're paying $9 per book, so multiply 9, the cost, by the number of books, so 9B, plus we have to pay this $81,395 no matter what. So now we can work on solving this equation. I'd say I'll probably subtract 9B from both sides, since that's the smaller amount. So $24.50 minus 9B gives me $15.50B. And then if I have all the B's on the left, I might want to subtract all the numbers over to the right. So we'll subtract this 21,193 for both sides. And on the right, we end up with 60,202. 9 minus 5, 9 minus 9. So then very last, we want to divide both sides by 1550, because we're trying to get B all by itself. And so 60,000 divided by 1550 gives me 3,884. So it looks like it's also an even number of books where it breaks even. And so now we want to write our answer, a nice whole instead of just a variable. So method A is equal to method B when we produce 3,884 books is the break-even point.